Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here live at Van Horn Elementary School, home of the Hornets, and today we're all here to do the math!
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott, and we would love to have you be part of our TV show today. If you happen to have a math question and you would like some help with it, give us a call if you're here in Bakersfield. The number is 636-4357. If you're in San Luis Obispo, you can also give us a call. The number is toll-free, 866-636-6284. You can even email us your math question if you happen to have one. dothemath@kern.org. And of course, social media, we are on all those platforms, Facebook, Instagram, Twitter, and YouTube.
All right, as a matter of fact, there's a contest going on.
I heard about
for
that.
the students in San Luis Obispo County. There are 2 elementary schools, and they're going head to head to find out which of the schools will call in most between now and December. And we can see that it is Grover Beach and Ocean View Elementary, and those 2 classrooms, those 2 schools, have put forth a little challenge for themselves to see which one can call in the most. The school that phones in the most, the top students will be going to Doc Bernstein's Ice Cream Lab, the secret facility, shall we say, where they make all the goods. A nice new facility, I understand, as well. Excited to go myself if they'll let me go over. And then the top student will be receiving a golden ticket.
Heard about that too.
In Willy Wonka.
Yeah.
A Sunday a month for a year.
That's worth it, and a little help with the math.
Well, I'll tell you right now, I get a different one every time.
Yeah.
We'll maybe get the best one twice. But we do have phone tutors available. Ding, 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 indeed. We do have phone tutors available until 5:30 in the afternoon on most Tuesdays and Wednesdays throughout the regular school year. We do have a special guest in studio. We'll meet that young man in a little bit. We'll be going out live to Van Horn Elementary, meet with Devin, and I do believe we have our Science for Kern out there today as well, so we'll see what they're working on.
Yeah.
But before we get to all of that and the phone calls, let's first take a look at today's Math in the News. This I found in the Sunday newspaper, and with great anticipation, the day has finally arrived.
The day has arrived.
The day has arrived. Great anticipation. It is National Cheeseburger Day, September 18th. All celebrate. Have you ever heard of this before?
I've never heard of it, but I think it is the most amazing holiday I've ever heard.
I've never heard of it. I don't remember this ever happening before. Maybe it was on, I don't know if it's always September 18th or if it's a certain Tuesday in September.
I think we should make it the 18th of every month. How about that?
Oh, you know what? We have many holidays like Donny Day and every day. But anyway, National Cheeseburger Day is today. So they had some things in the newspaper about this.
Okay.
Condiments, ketchup and mustard, 37% of people say that's their thing to put on a burger.
Okay.
Only 13% say tomatoes.
Yeah, I'm part of the 87% on that one. Yeah.
Amazingly, bacon was only 12%.
And that statistic is just not right.
That
boggles my mind.
It does. That only 12% of the people say they would put bacon on their burger.
Yeah.
I can understand, the tomatoes, some people don't like the consistency, the taste, whatever it is.
Right.
Condiments, yeah, I would expect that to be kind of high. And those are the 2 most common.
Okay.
Some are added like mayonnaise and
whatever they
relishes,
got going. Yeah,
whatever,
sure.
things like that. But those are the 2 most common. So I figured we put a little bit of the percents in there to show some math. What do you think is the most popular chain for burgers in the United States?
Chain, like restaurant?
Right.
McDonald's. Be my guess.
Okay, now do you think that's different for California?
Oh, wow, that's a tough one. Well, I think the most popular would be In-N-Out, but I'm not sure if it's the most gone, the highest revenue. I'm not sure there, but I don't know if they have enough stores to beat McDonald's, but I think it's probably the most popular.
As
Oh,
far
here we
as
go.
the nation goes,
All right,
the top one is Five Guys.
all right.
And that's this burger right here, 25%.
Wow, that's pretty good.
All right, so that looks like a burger.
That does
ready
look
to be
pretty
had
good.
right there, huh? The next one is Wendy's,
All right.
and there's that.
Mostly because the burgers are square. Everybody wants something a little different.
A little bit.
The
you know,
square burger.
It's fine. Have a square burger if you want. You can make mine in pieces for all I care. McDonald's,
Yeah,
there
there
it
they
is. They're there.
Okay.
20% in the country. In-N-Out, 15%.
Yeah.
And they got 15% because California, Nevada, so large.
Right.
That's why they have got the 15%.
Well, I just got the download last weekend that there is an In-N-Out in Dallas, Texas.
Oh,
I didn't realize they'd gone that far, but
and
apparently
there
they're
are
there.
a lot of chains in other parts of the country
Right.
that aren't here. I mean, they're in certain sections of the country, and they're
Sure.
big there. I think
White
one,
Castle.
Whataburger.
A Whataburger, yeah, that's a big
Whataburger,
Texas one.
When
Yeah.
we went to Texas, that in New York, White Castle.
Right.
You know, back thing. But anyway, top cheeseburger chains listed right there, and that is today's Math in the News. Celebrating National Cheeseburger Day here on Do the Math. 636-4357 is the phone number. We do have phone tutors available until 5:30. In studio with us right now, we have Silas. How are you?
Good. How are you?
I'm wonderful myself. Why don't you let everybody know where you go to school and what grade you're in?
I am in 6th grade and I go to Stockdale Elementary.
All right. And how is 6th grade?
Pretty good so far.
Pretty good so far. What do you like best about it so far?
I heard there's Camp Keep coming up. So.
You are correct on that. And I think they just had something in the newspaper recently also about Camp Keep. What have you heard about it, or what do you know about it?
I know you go on like a 1 or 2 mile hikes, but that's all I've really heard about it.
Oh, a 1 or 2 mile is simply the beginning of your hike.
That's before breakfast.
That's before you get going on the actual trek and things like that. But you're going to have a lot of fun. You're going to learn a lot of things. And do you know when your school attends Camp Keep?
I think February.
Okay, so you've got a couple of months to learn some things and get ready for that and anticipate what's going to be happening over there. Well, you know what? We certainly do enjoy having you on air this afternoon. And what I'd like you to do is get to work now. You ready? All right, over to the board, young man. So, give me a single-digit number, Silas. 3. All right. In front of that, I want you to write a negative symbol. And in front of that negative symbol, I want you to put 9. All right. And Scott, before the 9, open a set of parentheses.
Like this?
Right.
Okay.
Inside of it, put 5 plus 2.
5 plus 2.
Close the parentheses.
Okay.
Silas, in front of that parentheses, give me another number. 4.
Good call.
All right. So let's leave it at that. Do you remember your order of operations?
To the
You
best
certainly
of my
hope so now,
ability.
huh?
Yeah.
All right. Let's go.
So what do you think, Silas? What's the first thing you want to do in this problem?
Add 5 and 2.
Okay, and I think a really good idea when I like to do these problems is just want to put some numbers over top. So the first thing you're going to do is here. What will be the next thing you're going to do?
Let's see.
Well, tell me about this. What is the operation that's going on over here with 4? It's right next to that parentheses, right?
Yeah, but
So what does that mean? If it's squished right next to the parentheses?
do we add that?
Almost, not quite. What's the other one? Times. Right?
Multiply. Yeah.
So what about on the back end? What's going on there?
You divide 9 by. Subtract 9 by 3.
What about the 9 part though? The 9's right next to the parentheses. What would you do there?
You would.
Let's make this a
Multiply.
little easier for you. So here's what we're going to do, because that could be a little confusing right
Okay.
now. So in front of the 9, would you like a positive or negative symbol?
I
A
like
plus
that.
or minus?
Positive.
Okay,
Good
go
idea.
ahead and put it in there.
Okay, so now we know what all the
There we
signs
go.
are.
Yeah.
All right, so the very first thing you're going to do is add the 5 and 2. What's the next thing you're going to do in this problem?
Multiply.
Good
the
job.
4.
That's right. Multiply. And then what's next? Going through the order of operations.
Yeah, I'm trying to think.
That's all right. As you go left or right, what would come next?
Add.
That's right. So there's the third one.
Yeah.
And then the last one will be right here. Okay, so I'm going to give you a little bit of room here. And I want you to do just one step at a time so you can keep it all straight, right? Okay, so we're going to keep the 4, right?
Mm-hmm.
Parentheses. Once you figure out the 5 plus 2 part there.
It would be 7.
Okay, so write a 7 in there. Good. And then you can, at the end, write plus 9 minus 3. And then minus 3 as well?
Minus
Good.
3.
Okay, so you said the second thing we're doing is at the beginning. So let's do the multiplication part. What's going to happen there?
That would be 28.
Good. Write 28. Yeah, I like how you did that little upside down arrow there. Good. Plus?
9 minus.
Don't do any math yet. Just put plus 9 minus 3.
All right.
We're just going to do one step at a time so we don't get confused. Takes a little bit longer, but it makes sure that we have the right answer at the end.
Okay.
What's next? Remember what you had? You had the plus sign next, okay? Let's do that one next.
Plus 9.
You can do that in your head.
8,
I'll give you the upside down arrow.
37.
That's pretty good to me. Oh, we'll make that a little bit different.
Yeah.
That's all right. Go ahead, try again. What goes in front there? Good. 37. And then we have anything left?
Yeah, we do better.
We do. Go ahead and stick that on the end.
Subtract it by
Right.
3.
So hold on. Don't do the math yet. Just put the minus 3 in. Good. And then the very last step. Now you can do this, right? Go ahead and finish up that part at the very end. Good job. Well done. I like how you worked that problem out. Good stuff.
Nicely done, Silas. Thank you for that. Hey, we do have phone tutors available until 5:30 this afternoon, so if you need any math help, we are here until 5:30. Right now, we're going to go out live with Devin and check out our friends from Science for Kern.
Hey, thanks a lot, Mike. We're here at Van Horn Elementary. It's our first Science for Kern challenge of the school year. I'm here joined by Michelle. Michelle, great to see you again.
It's good to see you again, too.
We're back. We're back. It's another season
Exciting.
of challenges. So tell us a little bit about Science for Kern if people have not come in and viewed this with us before.
Well, Science for Kern is a mobile lending library of science equipment for 4th and 5th grade teachers here in Kern County. And you just have to be a 4th or 5th grade teacher teaching anywhere in Kern County to access the materials. All materials are accessed through the Science for Kern website. The materials come with all the hands-on equipment needed to do the activities. There's a teacher's manual. Everything gets delivered. A credentialed teacher will come and teach the first lesson. And then after the teacher teaches a couple more subsequent follow-up lessons, the materials get picked up by our Science for Kern team and cleaned up and refurbished and ready to go for the next school site. And it's free.
That's key, right? Did you get that last part?
Free.
Okay. So with that in mind, you know, a lot of the instruction really isn't very direct. A lot of it is based around these challenges. So tell us a little bit about the kinds of challenges that students interact with, or actually we'll have one here today.
In the Science for Kern program, the activities are based on the California NGSS science standards, covering 4th and 5th grade content only. But they do come with hands-on materials, as well as building activities and the such that they're going to see here today.
Well, with that said, we've already got our groups here. Say hi to everybody. So we got about 12 of our fighters from Van Horn Elementary, and let's kick things off.
We're working on building a shade structure. The students have been given the challenge to build a shade structure that is going to protect a piece of ice from melting. Later in the episode, we will be testing our shade structure. We do have some building materials today. We are using straws and popsicle sticks and construction paper and felt and note cards, tape. Scissors are there as a tool if they would like to cut anything into a smaller piece. They can even use the bag as part of their construction materials if they wish. We already have some students who have been designing what their shade structure is going to look like. So you may now go ahead and open up the bag and start construction, and we're going to come around and have you describe to us what your shade structure is going to look like. So ladies, tell us about your design.
Well, our design is going to have a bag and fabric under it so it won't glare on the ice, and paper so it can have protection, and then the popsicle sticks are going to hold it.
Okay, so how many? Oh, 4 popsicle sticks. And where's the ice cube going to go?
Right here.
All right, good luck. So gentlemen, tell us about your design.
So we're going to add, you do it.
Fine. Okay, we're gonna add the brown fabric around the ice cube first. So, and then we're going to have this construction paper to wrap it around so the heat won't come in. And we will put these popsicle sticks under because the ground is gonna be hot, and we don't want the ice cube to melt from the bottom. And
So you're going to have a buffer between the ice and the blacktop?
I'm gonna have the construction paper and the popsicle sticks and the fabric so it doesn't melt. And then we're gonna add more construction paper, this one, all around it. And last, we're gonna use the tape to wrap it around.
Ooh, that sounds like a fabulous design. It'll be interesting to see what sort of success you have with that. What are you ladies going to do? Tell us about your design.
So what we're gonna do is we're gonna start with the toothpicks, and we're gonna put them on the, not toothpicks, straws, and put them on the bottom and put paper on top to keep the heat away. And we're gonna put sticks on the sides to like hold it together. And we're gonna put the ice cube inside, and if we have Q-tips left over, we're gonna put them under the ice cube, and we're gonna put the fabric on.
Oh, is the fabric going to go over the top? Okay.
Like it's gonna hold where the ice cube is, so it doesn't like.
So the ice cube doesn't what? Okay. Are you going to put the ice cube on the ground?
No, we're putting it under toothpicks.
Okay. Tell us about your design, ladies.
Oh, so what we're doing is we're going to put the construction paper on the bottom because we don't want it to melt through. And then we're going to do the popsicle sticks as like a stand to kind of hold the top. And then do you want to explain?
Yeah, and then the rest of our woods we're gonna put for the first layer, and then after that we're gonna put some sticks on top of that, and then the float.
We're going to cut our straws and then place them on like that. And then we're going to put a piece of felt over the straws.
Terrific. I can hardly wait to see how that goes. So gentlemen, tell us about your design.
What we're doing is we are making the project. We put so these 2 straws will be holding a piece of paper to cover the top. We will add like a little piece right here to put more shades, so the sun will be like right here, and the ice will be right here. So the shade will block the sun so it would not melt.
Okay, that sounds terrific. We'll see how that goes when we do our test a little bit later. All right, so tell us about your design.
What we're gonna do is we're creating little pairs like this, and we're gonna put 4 edges of them, which will. We haven't gotten the design completely ready yet, but it's gonna be able to have a light roof because we don't want it to be too heavy.
Which material are you going to be using for your roof?
For the roof, either a piece like this. So, actually, we should probably use the construction paper because it's just dark. That way it'll block more light out.
Okay.
And what I was thinking, I don't want it to be too heavy or else more heat will stay in.
So will you use the entire sheet of construction paper, or are you planning to cut it?
And we'll have 4 corners. I'm hoping a little piece like
Constructed this way?
yes.
Okay.
So
That way they can be the corners.
we're going to go ahead and take a look at these designs as they're further along in the process. Design thinking is happening, and in our next segment, we're going to see where the ideas exist from their origin to then where the model grows. So we're going to get a chance to see what that looks like in a little bit. But for now, we'll send it back to the studio. Mike, take it away.
All right, thanks for that, Devin. Thanks to all the students out at Van Horn Elementary and our friends from Science for Kern. And we all can tell that Devin and myself really need that shade structure when we're outside. So we're always looking for new and improved shade structures. 636-4357 is the phone number. We do have phone tutors available until 5:30. Don't forget, we have also a contest going on in San Luis Obispo County. We had a couple of students phone in from Grover Beach Elementary, and the last I looked at, the tally altogether has them up by a few phone calls. So remember, this is a contest that goes every day from now through December, and we'll get to some of those problems in just a little bit. Right now, we have Silas in studio, going to get him back to work. So let's go ahead and take a look at the problem that Silas was working on. This is part of his homework. So also on the news broadcast, a chef from a local Italian restaurant demonstrated how he makes fresh pasta daily for the restaurant. The recipe for the pasta is, and we can see the different items are listed. Determine the ratio of the number of tablespoons of water to the number of eggs. So what Silas did was he started doing this, and we can see, Silas, as those graphs are up there in those tables, explain to us a little bit the process of what you were doing.
So if you look up on the paper, it would say like more above, it would say like there are 3 eggs, so I know I have to keep going up.
Okay, so go ahead and put 3 in there. So if you were just making a little bit of the, if you're making one batch of pasta, right? 2 tablespoons of water, 3 eggs. Good. So where do these numbers come from then? How come they went up by 2s? Is it just easy to double?
Yeah, you
Okay.
just, yeah.
So we add another batch, add another batch, add another batch. What's happening to the eggs?
They're adding up by 3.
Okay, so give us a little example of what that's going to look
That
like.
would be 6,
Okay.
and then that would be 9,
Good.
12, 15.
Good, okay. So this side looks like you came up with a pattern of +2.
Yeah.
And this side you came up with a pattern of +3. Great, wonderful. So it looks like you have a nice little ratio or something like that going on here, right? Because really what we'd like to know ultimately, and this is what math usually is trying to get to, is how do we go from the left side of the column to the right side? So for instance, one of the patterns we could use is 2 plus 1 is 3, right? But whatever pattern we use, we have to have it for all of them. So let's see, 2 plus 1 is 3, 4 plus 1 is not 6.
Yeah.
So the pattern is not +1. So what did you do to come up with a pattern so that if you wanted to know if you had 50 tablespoons of water, how many eggs you'd have, and you wouldn't have to make a chart that went on for 4 pages?
Yeah, well, if you see like 2 plus 1 is 3, and then it keeps going up, so that like there's 1, and then like 4 plus 2, 6.
Okay.
Yeah.
So there is a pattern there, +1, +2, +3,
Yeah.
+4, right? So again, if we had this number way down here, and you had 50 tablespoons, it's supposed to be a 5, 50 tablespoons of water, you wouldn't know what to add though, right? So we would really like to know how to go from the left-hand side to the right-hand side without having to add something. So what did you do with that?
Let's see.
You had yourself a little graph, right?
Yeah.
So let's make a little sketch of this graph here real quick. Show us a little bit about this graph and what you did with that.
So, there's like lines, and then like you're supposed to like put numbers on the bottom here to like 4, 6.
Sure.
And then like you would have to write. There would have to be like lines for me to
Sure.
show you.
Well, that's okay.
but-
We're just going to make a little sketch here. So you're saying these numbers down here, that's a 2, that's a 4,
Yeah.
that's a 6, and 8, and 10, right? Okay, good. So over here, you want to go by 3s. 3, 6, 9, 12, 15, 18. What does this one represent over here? What are we talking about?
These represent the tablespoons.
The eggs on this left side, right? And on the bottom?
No, yeah, sorry, the other way
we got
around.
tablespoons there. That's okay. So show us a little sketch of what this graph would look like if you were to graph it.
If, let's see, that's 2, there would be, you would go up by 2 and then put a 3
Okay,
here.
put a dot with it. Where do you think that goes?
But somewhere like right here.
Okay, and what about the next point?
And then the next one would be
Over to
somewhere
4, right?
here, yeah.
And up to 6.
And then up, it would keep going up and to the right.
Gotcha, up and to the right. Okay. And then this This part that you're talking about goes up and over and up
Yeah.
and over and up and over. It was a good little pattern to go there.
Yeah.
How far does it go up every time?
I think.
That's this side. How far does it go up every time? Here's our pattern.
Oh, 3.
Good. So it's going up 3 every time. I like that. And how far does it go over every time?
2.
Exactly. So we got 2 here and 2 here and 2 here. And that makes a nice little ratio, or in other words, the slope of this line, right? And what is the slope of that line? Remember how that goes?
What?
The slope is usually a fraction, so let's make a fraction out of it.
So there would be like 3.
So while you guys work on that for a moment, what we're going to do is we're going to peek in real quick, and we're going to go back out to Van Horn Elementary while they're working on those structures, and we're going to take a little peek in at what they're doing. So you guys can keep working on that right now for a moment, and we'll take a look and see how they're doing on these structures right here. And we can see that the students are getting their materials, kind of putting everything together and coming up with some basic ideas right now on the construction of it. And always fun to have a lot of tape in the classroom and see how things are put together. It looks like they've got some straws, some paper right there. And I would imagine that's going to be one of the supports, especially since it's clear.
Yeah.
And then using the paper right there. And we will check back in with Devin and the folks from Science for Kern and see how they're doing at Van Horn Elementary in just a few moments. All right, Silas, how are you guys doing on your slope?
Well, if.
Let's make a big line. How about
yeah.
that? Okay, we got a big line here. We want to know how steep that line is, right? You made a wonderful line. So tell me a little bit about the slope. Do you remember how to make a slope? Remember, it's a fraction.
Yeah.
Just tell me a little bit about slope. What's going on in your mind about slope?
It's going up.
It is going up, that's true.
by,
So is this a positive or negative slope?
Positive.
It is a positive slope, so that's good. We got that part. I like how you said that. You ever heard of rise over run?
No, I haven't.
Okay, well that's kind of
This
a bonus.
is something I think, have you done this in class yet?
We've done this in class.
So
a
rise
bit.
over run and slope and things?
Well, not rise over row, but we
Yeah.
have done graphing like this.
Good.
Well, this is a big day for you because you are going to be doing this
That's
in
right.
junior high school. So
And it's super straightforward. Are you ready? How far does this line rise every time?
3.
3. There you go. How far does it run every time?
2.
That's it. So guess what? There's a slope.
Okay.
And that's kind of the ratio we were talking about earlier, right? You were looking for a ratio that would help us describe this thing. So the nice part is, if you took this number and multiplied times your ratio, that's how you get the other number. So we have a nice pattern here, right? 8, can you work out this problem here for me? 8 times 3 over 2. How would you do that problem?
Well, wouldn't you multiply this by the
Show me.
second
Yeah,
number?
you know
I
what to do.
think?
It's fractions. Watch your hand there.
Sorry. So that would be 24.
Good, 24 over.
Let's see, that would be 2.
Uh-huh. And what's 24 divided by 2? Just in your head.
12.
Good, look at this. 8 goes to 12. So that's how we can do it. So now, are you ready for the big question here, right? If you had 50 tablespoons of water, 50 of them,
Okay.
and you want to know how many eggs you need, we can use our pattern here. Let's do that. Let's see how many eggs you need. 50 times 3 over 2.
Okay, 50.
Watch your hand there. Good, there you go. Good idea.
That would be 0.
Uh-huh.
50.
Good.
That would-
150
Mhm.
over?
2.
Now what is that?
150 divided by 2. Wait, yeah, 150 divided by 2.
Right. What is 150 divided by 2?
It is 1.
If you had $1.50, what's half of that?
50.
It's okay. We can work it out. No problem.
Yeah, I need to.
Hooray
do
for
that.
math. Try it.
Let's see, 15, 17.
7. Good
7.
job.
Wait,
You're okay. That area of the board doesn't always like us. I'm going to move it up for you. Good.
do that,
Mm-hmm.
do that. Down your.
I like how you put the arrow there so you don't forget the 0.
Yeah.
All right, so how many times does 2 go into 10?
5.
5. So instead of making your chart go 12, 14, 16, 18, 20, all the way down to 50, I mean, that could take up 5 pages, right? We can use this little ratio right here and find out that if you had 50 tablespoons of water, you would use
75.
75 eggs. And that is the beauty of finding the slope of the line, because then you can take a little shortcut if you're looking for a bigger number.
Nicely done. Speaking of pasta, they have pasta and pizza at Cubby's. And because you've been doing some great work today, we are going to send you over to Cubby's to enjoy a meal over there. So nicely done on that, Silas. 636-4357 is the phone number. We'll be back with more right after this. Today we're in Boron. We're at West Boron Elementary School, home of the Jackrabbits, and today we're here to... We're at West Boron Elementary. We've got some 6th grade students, and we're going to do a little work with numbers and operations. All right? So let's see how many of you guys remember this, or if you've even heard of this. Does anybody have any idea what's going on here? And what does it stand for? I mean,
parentheses,
well, hold on there, brother.
multiplication, division, addition, subtraction.
We've got her right here. All right.
Parentheses, exponents, multiplication, division, addition, and subtraction.
And does anybody ever remember hearing a saying for that instead of parentheses, exponents, multiplication, division?
My 5th and 4th grade teacher, he used to do this like every single day. Before he actually assigned us math work, he would make us do math notes.
Okay.
And we would always do like a couple appendix problems.
Perfect.
And he would sometimes have us write it out, parentheses, exponents, multiplication, division, addition, subtraction.
And obviously it worked doing it every day because now you remember that. But do you remember a saying that went with it?
Please excuse my dear Aunt Sally.
Do you have an Aunt Sally? No. But you know who it is now, right? Yeah. It has something to do with math, right? So it's just a way for you to remember the order of operations, right? So that's what we're going to do. We're going to do a little bit of work with the order of operations. So what are some different operations? What are some symbols we're going to need? What's this one?
Addition.
Addition, right? So we're going to need that, right? What other symbols are we going to need?
Subtract.
A subtraction sign.
Division.
Division. And there's 2 different ways we could do division. We could do it like that, or we could do it like that, right? What else? Multiplication. Would that be multiplication? Could this be multiplication?
Yes.
Could this imply multiplication from what's outside to what's inside?
Yes.
Right, because if I had 2 and then parentheses 3, what does this mean? 2 times 3, right? So there's a couple of different ways we could write multiplication, okay? So here's what I'm going to have you guys do, all right? Your task is to use 4 fours, okay? You can only use 4 fours, all right? So on your paper, it's going to look something like this. And in between the 4s, you're going to put different operation symbols, okay? You have to use 4 fours. You can't use 3, you can't use 2, you have to use all 4, and you can't use any more than 4, okay? What I want you to do is I want you to use 4 fours, and what grade are you guys in?
6th.
6th. So I want it to equal 6. All right? So that's the challenge you have. You have to use 4 fours. You can use parentheses. Now, exponents is going to be kind of hard because you would have to do 4 to the 4th, which would be a pretty large number if you're trying to get it to equal 6. All right? So you guys remember how to do order of operations? All right, let's go ahead and get started. You can work it out however you want. You want it to come out to equal 6. All right? Go. And right now the students are working on using 4 4s to equal 6 because they're in 6th grade. And what we'll do is we'll let them work a little bit, and when we come back next time, we'll see how they came up with their answers, if they indeed get 6 as the final answer. And once again, we do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. We have Silas, a 6th grade student, in studio with us. We'll get him back to work in a little bit. But first, we're going to go back out and check out with Devin and Van Horn and see how they're doing with Science for Kern.
Hey, thanks a lot, Mike. We're back here at Van Horn Elementary. Science for Kern is back with Michelle. Hey, we are just right in the heart of this activity. For those of you just joining us, let's kind of catch everybody up on where we are and what we're doing.
Okay, great. We are in the middle of our shade structure challenge, our playground shade structure challenge, and our mission is to build a shade structure using these designated building materials to protect our ice cube when we move outside during the next break to test our structure.
So just a little bit of a catch-up on where our weather is for those of you not joining us from the Bakersfield or California area. It's about, well, let's say 85 degrees outside today,
Right.
sunny, not cloudy, so plenty of energy to come from the sun to have an impact on our ice cubes. So we're really looking for the structures that are going to be protecting the cube. The idea that it could be a model to scale out larger, but the objective is to protect the cube more than anything else.
Correct. We'll have a cube outside the structure and an ice cube inside the structure, and compare the melting rate of each ice cube.
Well, let's go ahead and check out how far along our designs have progressed.
All right, so tell us about what you've done so far and why you've made some of these decisions in terms of your design and the materials that you've chosen to use.
Well, what we've done so far is we've basically cut this out and made these, which are kind of difficult because they kept falling off. And
Okay, so what are these?
they're just basically corners. I'll let you.
Okay, go ahead.
They're actually just popsicle sticks put together to like.
Okay, so can you tell us a little bit about why posts on the edge and what this part on the top is, what purpose it's going to serve?
The piece on the top is going to give the shade for the ice cube.
Okay.
And
the point where the ice cube will go.
We'll go
Point to
right
this.
here, and we're going to have a piece right here, and the piece right here is going to be faced towards the sun.
Okay.
Made out of this, blocking out most of the sun. The reason I've chosen this color is because being brown and a dark color blocks out more sunlight than something like light blue would.
All right. Okay, so we look forward to seeing what your finished structure looks like.
I hope you do.
All right, gentlemen. Tell us about what you've done so far and why you've made some of these decisions about your design.
the reason why we are doing this is because we want to add a roof so it can block the area of the sun.
Okay.
And the bottom is because we do not want a rocky surface hitting the ice cube because it can make holes in it.
Okay.
And they could crush the ice. And we have
So are you going to put holes somewhere? Is that what you said?
No, the hard blacktop.
Oh, okay.
Will, crush like little pieces of the ice. So we don't want that happening. So we add a soft surface.
Okay, so can you point to where the ice cube will go when we move outside to test?
Will be right here because this area right here is the darkest area of the shade.
All right, well, we'll come back to you and can hardly wait to see how that works. So how's it going, girls?
It's going pretty good.
All right, tell us about what you've done so far and where you're headed and why you've made these sorts of decisions about construction.
So we decided that we were going to make the wood kind of the first layer of our top.
So what do you mean by top?
Like it's gonna be the roof.
Oh, that's your roof.
Yeah.
Okay.
So then we're gonna have that, and then we're gonna add some straws that match the size, and then we're gonna put some felt over that. So and then we're gonna put a piece of construction paper at the bottom, and then we're gonna be using the index cards to make to block out all the shades from all the different sides, so no shade can get in from different angles.
So you'll have, how many walls will you have?
4.
Oh, okay.
Maybe.
Terrific. So this is your roof,
Yeah.
Yes.
and where will the ice cube go?
The ice cube will go
Right
in
in the
center.
middle. So we'll make a door kind of so we can open it and then put the ice cube in.
All right, sounds terrific. We'll let you get back to building. All right, ladies, how is it coming along? Tell us about what you've done so far and why.
We've been doing the fabric with the toothpicks because if we do it, the toothpicks will keep the egg from getting heat.
The egg, it's ice.
The ice.
That's okay.
The ice from getting melted because when it's not really much holes in the fabric or anything, it won't melt it. So we're going to try to do as much coverage as we can.
Are you going to do any sort of building construction that will hold up your roof, or is your roof going to lay down here? Tell me about that.
We're going to do some extraction, probably doing some straws by cutting them and probably trying to do about this big and putting the egg under. And we're thinking of having more tissue, fabric to put under the egg so it won't not egg.
Under the ice?
Under
I
the
know what
ice.
you mean.
So it won't no.
Okay.
And we're gonna put paper under it so it doesn't sit on the floor or anything.
All right. So if you have paper on the ground and you put the ice cube on top, do you think that that will help the ice to not melt, or do you?
Yeah, because we're gonna put this right here and put the ice cube on top.
Okay, how will that help?
Because instead of it sitting on the hot, probably burning ground or something,
Okay.
we have this to not make it hot or melt. And we're gonna put it like this. And if we still have more straws, we're probably gonna put some here.
All right, that sounds great. All right, boys, tell us about what you've done so far.
So we paved this.
And so what part of your structure is this?
I'm gonna say it. This is the.
Are these the walls?
Is it the wall camera?
Yes, alright, okay. So first we, cause last time I was we just did it like this, but I was since we have extra, we could put extra protection. So I put this inside, and to make sure I made it big enough so the ice cube can still fit. And I was gonna put it in here, and I put tape on this, so if I put this in, it will stay.
Oh my gosh, so how many layers do you have there?
Oh. This is the 4th layer of the yellow, and then we're gonna put it in this paper bag, and then we're gonna have the roof and put it.
Wow.
And do it like that.
So you have some crazy layers of insulation going on there. Each of these layers that you've added are going to insulate that ice cube. Is that what you're thinking?
Yes.
All right, can hardly wait to see how that works out. So tell us about your design.
We changed our design from the first start because
Oh, you did?
Yeah.
How come?
Because the bag and the popsicle sticks and the paper didn't really go with the tape, so
Okay.
we changed the bag to the bottom. And so also the bag blocks the sun from this side,
Okay.
so the ice wouldn't melt as fast.
All right, so is this completed, or you have more work to do?
Maybe more work.
So tell me about what you're thinking of doing to continue to add and redesign your shade structure.
Maybe try to put more popsicle sticks on the side.
Okay, and what would that do?
Try to hold it up more, don't.
Okay, maybe give it more stability on the side? Okay, so where does the ice cube go in there?
Right there.
Oh, the star is where the ice cube goes.
So what's really interesting is that a lot of these designs seem to be built around the idea of insulation and using layers to protect the floor from the ice cube instead of simply just the roof. So when we come back for our final segment, we're actually going to take our models outside. We're going to see how well they hold up. Until then, we're going to send back to the studio. Mike, take it away.
All right, thanks for that, Devin, and our friends out at Van Horn Elementary. We're going to have Silas work on a little bit more of the problem. We have a number here, and this is another little something for you to do. So it says, determine how many tablespoons of water will be needed if you have 36 eggs. Now, I know you and Scott went all the way to 50 eggs. So there's a couple of ways you could do this if you did 12, and then you could do what you were doing, or there's probably another way you might be able to solve it.
And you said that your problem said 36 eggs, right?
36 eggs.
Yeah,
so now we need to know
would be
how
going
much water
backwards
you
in
need.
this case. So if you had 36 eggs, we would want to go backwards to the water. So if we went from water to eggs and we multiplied times 3/2, if you're going from eggs to water, what do you think you could do?
Divide.
I like it.
Okay.
I like it. What are you going to divide by?
So
36
by
divided by what?
2.
How about just
Yeah,
3/2? Same
3
thing,
over
right?
2.
Let's see if it works and makes sense. Now this number should be smaller, so show us how to do this problem right here. We'll put that over 1 for you. Off you go.
All right. So if
What are you going to do when you divide fractions?
put like an equal and then put like a line for the.
Show me. Go ahead. If you
Here.
make a mistake,
Let
we
me
can always
just show
erase.
you.
Watch your hand there.
And then like I think.
All right. So we have a little bit of work to do on dividing fractions, right?
Yeah.
All right. So let's see if we can try this again. I don't know if you remember. Do you know anything about a word called the reciprocal?
No.
Reciprocal means flip it over. So when you divide fractions, we have to make a brand new fraction. We keep the same one at the beginning, but then we would love for this to change. We want to change that to a multiplication sign and then flip it over. 2/3. So now let's see if we can solve this problem because we want this number to be smaller than 36.
All right. What?
36 times 2?
Yeah.
Here, let me give you a little more room there.
Yeah.
Yep, there you go.
That would be 7.
Good. 72. All right, so we got 72 up here. And what's 3 times 1?
And 3.
Good. So right over here, I'm going to have you do this final part. 72 divided by 3. What do you get there?
Let's see.
Remember, this number needs to be less than 36, so I hope that's going to work out.
Yeah. So wait.
That's okay. Try again. How many times does 3 go into 7?
2.
2 times. Good.
And then we
And
put
that's
the
where the
6
6
right
goes.
there.
Yeah.
2 down here.
Mhm.
That 12, and then that would be 4.
Good. So let's see if that works on our numbers up here.
4.
24 would be the number of tablespoons of water, and 36 would be the number of eggs. I like how you did that. So we have a nice pattern here that no matter how many eggs Mike gave us, we could figure out how many tablespoons of water. Good pattern to use.
All right, nicely done, boys. You know what? I'm going to have you erase that board, and Silas, I'm going to have you come over here for a moment. You can relax for a couple of moments. And we had a couple of students call in from Grover Beach Elementary.
Okay.
And there was one student in particular, a 3rd grade student, learning how to multiply and therefore learning how to divide rather soon.
Okay.
So one of the problems they had was 6 times
6
the
times.
infamous box
The empty box.
is equal to 36.
Okay.
And she just wanted to get some ideas on how to multiply and some different ways to approach this as she's learning it in 3rd grade. So Silas, come on over with me. We'll take a break. And then if Scott needs some help, we'll assist him later.
Heck of a deal. Thank you, gentlemen. I appreciate that. Well, sometimes I like to think of multiplication as groups. So we have 6 groups of whatever we have here. So if you had 6 groups, 1, 2, 3, 4, 5, 6 groups, and you added them all together, then you would get 36. And your job is to figure out how many would be inside each one of the groups. And so that's kind of a fun way to do it. You could draw some pictures. But what if you had 1 in each one? Well, that's only 6. That doesn't work out very well. What if you had 5 in each one? 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. Takes a little while. 1, 2, 3, 4. 1, 2, 3, 4. If you had 5 in each one, 5, 10, 15, 20, 25, 30, we're so close. So you could do a little bit of experimentation, but I always like to have pictures because pictures you can actually see what's going on. If you have 6 in each one of these groups, then you can see 6, 12, 18, 24, 30, 36. So that's one way to get the 6 in there by drawing a picture. It's kind of a fun way to do it. Another way you could do it is you could take this answer here, and because it's on the other side of the equal sign, you could do the opposite of what this says. You could do the opposite of multiplication. So, excuse me, 36 divided by 6, that's what gets you 6 here. So lots of different ways to multiply, and you can look forward to doing some fun algebra when the box becomes an X later on.
Yeah, and that's going to happen rather soon.
That's going to come, that's right.
That's nicely done right there. Hopefully that helps out the student in 3rd grade over at Grover Beach Elementary. And if you need some more help, we do have phone tutors available until 5:30. And that way the phone tutors can take a little bit of extra time with you. And like you did, you wanted to see something worked out on the board, so it's a little bit easier to understand. All you have to do is ask them, and then by all means, we'll put it right through and we'll work it out on the board. We do have phone tutors available until 5:30, and once again, we're going to go out and we're going to check with the kids out at Van Horn Elementary in a bit. It looks as though they are going out to the playground, and they might be going out to the actual shade structure they have with the items that they have built. And if I'm not mistaken, they may have something out there, they might have some ice or something else to see how this is actually going to work. So what we'll do is we'll head back out there with Science for Kern and Devin and see what's going on at Van Horn Elementary. So we will check in with those guys in just a moment. So one more thing that you were working on in class, and why don't you go on over to, you know what, you can just stay right here if you want, because we're just going to talk about this. So let's look at this. This is a little mat that you had done in class, and it had to do with the problem you were working on. So explain to me, first of all, what's going on in that part of this mat.
Okay, so if you have to like write the problem off of the actual math paper into the thing and then work it out and
Okay, so up here, this application, right? So you're just writing down the problem that you have to solve, the specific one, right? So what about the next part here? It says to draw, and it has conceptual understanding. So what are you doing in that part of this?
Drawing a graph and figuring out which, like what are the numbers to the right of the graph.
Okay, so, and is this something that they provided you with, or did you come up with that on your own?
They did not provide, well, they did, but only like the first number, and then we had to figure out the rest.
Okay, so by doing that diagram, you were able to figure out the other numbers coming up, all right? And let's take a look at this last part right here, and it's got the procedure, basically. And explain to us a little bit about what you did there.
Well, every time you add 3 more eggs, you have to, like, if you have 3 and then you just got to keep like adding by 3 and fill in the graph.
Okay.
So.
And this is able to help you out understand the math problem a little bit easier?
Yeah.
Well, there you go, and that's exactly what we want. Whatever tools you need to help you understand the math as you're going along. All right, we're going to go out one more time, check out with Devin at Van Horn and Science for Kern. You know what, it seems as though they have a little problem with their audio right there. We can see that the students went outside at Van Horn Elementary and they were working on those shade structures right there. And I think what they're doing is they're now going to determine how well they work. Because I think what they were going to do is they were actually going to give them some ice.
Oh, okay.
And then we'll go out there and we'll go back out and see what's going on.
My
much grander.
So girls, can you explain just a little bit about why you think there's such a difference between the rate of melting inside the shade structure versus the outside?
Well, that one's outside, and the sun's hitting it.
Okay.
Well, that one's inside, but it can still melt because of the heat too.
Okay. So how does that ground feel? Are you getting any heat up off the ground?
Yeah.
Okay. So do you think that has anything to do with the melting?
Yes.
Okay. How so?
Because it's already hot, and the stones get reflected off the side.
So if you could make a change, what would that one change be?
Maybe putting more protection on the walls.
More protection on the walls?
Yes.
Okay.
There's a couple more groups I want to check out. I kind of noticed that some of the groups got very curious with that ice cube. They started touching the ice cube, and we don't want that because that's going to transfer energy faster into the ice cube and melt it faster. So that kind of throws everything off. I wanted to come over here in particular because of how much of the ice cube is remaining on the original. That thing is gone. Look at this. Look how much, very little we have left here. So let's take a peek inside of our device here. Oh, they use almost the entire bag.
Can you tilt it so
let's see if we can tilt it so that we can see it on camera here. I mean, basically, if there's anything left of that ice cube, we're in good shape because you created a full protective coating and many different layers there.
Yeah. So tell us a little bit about what are you thinking if you were to make any changes or modifications to your design?
If I would have made any changes, if I had more maybe popsicle sticks, we could.
And what would you do with them?
I would have probably made the idea I first did, but we found out that we only had 8 little popsicle sticks.
And so what was your first idea?
Our first idea was to do probably 15 popsicle sticks on a couple of the sides, and we were gonna do this to protect this way, and we were gonna put straws and those pink papers on top to keep it from melting, but we found out, so we did the bag with tape and a lot of tape and straws.
Yeah, I would say that your first draft there is a success. So tell us about what's going on, guys.
That one already melted.
Get it, come up.
Inside is better dyed. The inside of this one is still in.
So what used to be here? What was here?
Ice.
What happened?
It straight up melted.
Let's hold a moment of remembrance for our fallen ice brothers and sisters.
God.
Ladies and gentlemen, a wonderful day here at Van Horn Elementary School. Science for Current, thank you so much. Right now we're going to send it back to the studio to wrap up the day. Mike, take it away.
All right, thanks again to Devin and Michelle and all of the folks from Science for Kern and Van Horn Elementary. Certainly a great day out there. 636-4357 is the phone number. We have phone tutors available until 5:30. Just a reminder, we do have that contest going on for the students over in San Luis Obispo County between the two schools, and those students will have an opportunity to grab the golden ticket, and we have one right here. So the student that phones in the most from San Luis Obispo County, those two schools, will receive the golden ticket, and that will happen in sometime in December. And yes, ice cream, ice cream, ice cream. Always a fun deal right there. And we want to say thank you to Silas for coming in. Thank you.
Thanks, Silas.
Did you have a good time?
Yes, I did.
Well, good. I'm glad you did, and we can see that you now have your new uniform on. You are an ambassador for Do the Math. You know what that means?
So it means like I'm part of the.
You are
Spread
part
the
of the
word.
Do the Math family now.
Yeah.
That
That's
is
right.
indeed. So what we need you to do is tell other students about Do the Math and how they can just get math help if they need it.
Okay.
It's a pretty simple thing, isn't it?
Okay.
There you go. All right. We do have phone tutors until 5:30, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District. with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.